Welcome back, everybody. This is going to be our Algebra Essentials Lesson 1 Homework Review Part 2. This is part of our Algebra 2 section of learning. And so we're picking up on question number 4. Classify each of the following as either a monomial, single term, binomial, 2 terms, or trinomial, 3 terms. So what it comes down to is that just going to figure out just how many terms there are. And we said before, what separates one term from another is going to be an addition sign or subtraction sign. So our first one, part A, has only one term, therefore it's a monomial, and monomial. And I'm going to just type out the rest of these because my handwriting is terrible. All right, for B, we have negative 3x squared plus 2x minus 1. So again, there's 2 symbols in between, so there are 3 terms. This is going to be a trinomial. If I can type, it would be great. C, 16 minus x squared, only 2 terms there, so that would be a binomial. Now, just the whole idea of the word polynomial just means can be any algebraic expression with at least one term. And so here we have, all these are definitely defined as polynomials, even though the monomial has only one term. I'm going to type this out, monomial, for number 1, for the first one, monomial. Okay, so yeah, so even technically a monomial is considered a polynomial, even though poly means more than one, so it's kind of weird that way. So okay, so for D, there's x squared y squared. That x squared y squared is a single term by itself, plus, which means now second term, 25, only 2 terms, a binomial. Okay, now it looks like E has 5x squared divided by 3, but please remember anything multiplying, dividing, that's a single term. All right, so really it's 5/3 times x cubed. So we can rewrite this as, in this case, 5/3 times x cubed, and that's still a single term. So we would label this as a monomial. And finally, for F here, we have 16 plus 10t minus 4t squared. Notice it's a different letter, but still the same thing. We have 3 different terms, a trinomial. Now, in this case, what happens when you have more than one term, or 2 terms, 3 terms? 3 terms trinomial. What about 4 terms? Is it a quadnomial? Yeah, you could call it a quadnomial. What about 5 terms quinomial? Yeah, maybe, but you know what? At that point, it's called polynomial. Okay, so that's question number 4. Question number 5, use the distributive property first, and then combine each of the following linear expressions into a single equivalent binomial expression. So we're going to distribute, and so here we go. And, what, draw rainbows if we want to, a little rainbows to remind we're multiplying here. So we have 5 times 2x is 10x, plus 5 times 3 is 15. And then we're going to, here, multiply 4x and then minus 1 by positive 2 to get plus 8x. Minus 2. And so our like terms grouped together will be the 10x and the 8x. So we'll get 18x. And the 15 minus 2 gives us plus 13. And so this is the binomial that we have together here. All right, so for part B, 2 times 10x, and then 2 times 1 will give us 20x plus 2. Now, this is negative 3 times 4x and negative 3 times 5. So negative 3 times positive 4 is minus 12x. And negative 3 times negative 5 is positive 15. Please be very careful about the sign values. Okay, so here we go. Like terms are 20x and 12x to give us 20x minus 12x, in this case, is 8x. And the 2 plus 15 is 17. So our binomial is 8x plus 17. Okay. Here we go, right? Which of the following equivalence expression 2 times x minus 6 plus 4 times 2x plus 1 plus 3. And so we're going to use our word operations to multiply first, distribute. So 2 times x minus 6 is going to be 2x minus 12. The 4 times 2x and the 4 times 1 gives us 8x plus 4, and then we have plus 3. Now you're probably saying, why are we stacking it this way? Well, one of the great things about this, we can line up all like terms together in the same column. We can combine them as and together like we normally do in addition. And so you have negative 12 plus 3, so plus 4 plus 3. Well, negative 12 plus 4 would give us a value of -8. And then -8 plus 3 would give us -5. And of course, 2x plus 8x is 10x. So 10x minus 5. Now, one of the things we have to see in this case is that we can distribute all these, but we can also factor using our greatest common factor here. And the greatest common factor that goes into both terms would be 5. And so we factor out of 5. Now the remaining factor, well, how do we find that? Well, we'll take each of the terms, 10x, and divide by the GCF, which is 5, and the -5 divided by 5. Well, if we do that, we would get 10x divided by 5 is 2x. And -5 divided by 5 is -1. So therefore, this goes in here. So we have 2x minus 1. And therefore, this is the fully factored form of this expression combined, which would be, in this case, choice 2. Now, we could have multiplied everything out. That would be totally fine as well, too. But one of the things is we have other tools at disposal. Yes, this is going to be our review of algebraic essentials, but I want to see in this case, you pull from the tools you have. If you're struggling with factoring, you want to make sure you build this because in Algebra 2, it's so essential. It's so essential. Okay, all right, here we go. Question 7. Each step in simplifying expressions you worked with in 5 and 6 can be justified using one of the major properties of real numbers reviewed in the lesson. Justify each step below with either commutative, associative, or distributive properties when simplifying expression 8 times 3x plus 1 plus 2 times 5x plus 7. Well, here I'm probably going to type this out because my handwriting is just atrocious. Sorry about that. Okay, here we go. Let's see if we get a cursor here. So here, in this case, when we get the 24x plus 8 and plus the 10x plus 14, this is going to be the distributive property. Ooh. Distributive property. Oh, I see what happened. So, you know what? I'm going to just type in here, distributive property. Distributive property. Because we distributed using multiplication over addition. Okay, so that's the distributive property here. All right, there you go. Now for the next piece of work, we're going to do, we have here, we're going to have now the 24x plus 10x. So we see here that we are switching these two terms together and moving around. Well, that would be in this case the commutative property. Commutative property. Because the commutative property tells us that we can move the terms to addition, switch around addition, and still get the same exact answer. So this is all addition here. We can basically move the 24x plus 10x together first, and the 8 plus 14. So they are moved together. Okay. Now when we have the 24x plus 10x and the 8 plus 14 grouped together in this form, this is the property of the associative property. Oops. Associative. Oh, let's move over here. And let's stretch this out a little bit. Property. Okay, so the associative property is, in this case, the property we use when we are grouping things differently. We can group the numbers differently and still get the same exact result because the associative property works for addition. Okay, so now the next step. Well, here we combine the 8 plus 14 to get 22, but the x is pulled out or factored. Okay, so which property would this be? Well, technically it would be along the distributive property, but the reverse of this. So, okay, so I would say, my mind, I would say in this case, this is the, factoring. Okay, I call it factoring. Okay. Factoring. Okay. Factoring and addition. But one might see some people call the factoring part distributive property, and it's again factoring is like reverse distributive property. So that's the idea behind that. So we are going to factor and combine. So we add them together to a plus 14, and then finally we factor out the x from both the 24x and the 10x. Okay. All right. Now, one might say in this case, well, why don't we just add 24x plus 10x together first in like terms? I guess they want to see in this case to show that it works with only that we can add just numbers themselves and we have to worry about any other properties that deal and such, but it's still the same thing though, okay? And so this would be how we would group things together. And we finally get in this case 34 plus 22. The addition part is just adding here. So, but this is factoring, which in factoring is going to be another way of calling reverse distribution. Reverse distributive property. So that's one way to look at it as well too. You might call the factoring the reverse distributive property. Okay, and again, factoring is so important for us. Right, so just know that we'll be doing that quite a bit. So this ends our Algebra Essentials Lesson 1 whole review, Part 2, all the questions here, and hopefully this was a nice review for a lot of you guys and not so challenging, but if you had trouble, have questions or comments, leave them in the comment section below. I really appreciate the feedback and love to hear from you guys, okay? I hope you guys are having a restful time and just wound down the year. So this is just for a lot of people, a lot of review. As I'm doing this, it's more the end of the year for a lot of people taking geometry. But if you were watching this at the beginning of the year, hopefully this is helpful to you guys. Okay, so we'll be going over the next lesson for lesson 2 and the next video. So look out for that. If you found this video helpful, please give a like and also subscribe to the channel to know when new videos are added to the channel, especially if you are going to be following along for the study. All right, so just know that if you have questions, please contact us, and I just love to hear from you guys. Thanks so much for watching. I appreciate it. Take care and be safe.